Hello everyone, welcome to our second lecture for math. Today we're going to be going over decimals. You'll see a whole lot of overlap between decimals and everything that we talked about with whole numbers. There are only a few things that change or that you need to pay special attention to, and I will be sure to point those out for you. So first, why decimals? Decimals give us a lot more precision than whole numbers or fractions. Decimals tend to be easier to work with as well than fractions, and you will see that when we get into fractions next week. There are some decimals and their fractional counterparts that you should know. So these three right here, you should know those. 0.5, 5/10 is the same as 1/2, 25 hundredths is the same as 1/4, and 75 hundredths is the same as 3/4. Those are all numbers that you hopefully have seen before and are at least a little familiar with. Place value is another thing that changes a little bit, mostly when we're talking about our numbers in a decimal itself. So you see here our number before us, 5,134, and the decimal point is always and, 4,323 10,000ths. Hopefully you remember place value for our whole numbers from the last lecture. Remember, the first place value is ones, and then tens, and then hundreds and thousands, and then from there we progress 10,000s and 100,000s and millions. When we have a decimal in our number, like we have here, everything to the left of the decimal is our whole number. Everything to the right of our decimal is the actual decimal itself. Everything to the right of the decimal point. And decimals follow similar naming and similar place value in their naming, just with one little twist. So first thing hopefully you notice is that we go from ones to tens in our whole number. But with our decimal, our very first place value, this 4 right here, is the tenths place. There is no oneths place. We go from ones straight to tens. Think, if you will, about money. If you go shopping and you get, 5, 10 back in change, what are you going to get? You're going to get a $5 bill and 10 cents, a dime. So the very first place value that we see in decimals is the tenths place. Hopefully the other thing that you notice very quickly is that suffix on the end of all of our decimals, this THS. All place values for decimals should end in THS. That is what tells you that you're talking about a decimal versus a whole number. And this is something that's really important to pay attention to when you are rounding. Is your problem asking you to round to the nearest tens place or to the nearest tenths place? Are you rounding to the nearest thousands or the nearest thousandths? Make sure you're paying attention to that. So the first place value right after the decimal point, right to the right of it, is tenths. And then we follow the same pattern that we see in whole numbers. After that we have hundredths, and then thousandths, and then 10,000ths. Out here we would have 100,000ths. Then it would go to millionths, and 10 millionths, and 100 millionths, and billionths, and would keep going in the same pattern that we see with whole numbers. So make sure that you are very, very comfortable with your place value here. Find a number just at random and see if you can pick out one of the digits and see what place value it's in. So let's talk a little bit then about rounding decimals. Like I said, this is almost identical to rounding whole numbers, but make sure that you're paying attention to the suffix in your decimal if that's what you're rounding to. Is your problem asking you to round to the nearest thousand or round to the nearest thousandth? So for example, let's take a look at 3.524, or 3 and 524 thousandths. We want to round it to the nearest hundredths place, or hundredths place, sorry. So what number in 3.524 is in the hundredths place? Well, we know 3 is in our ones place, 5 is in the tenths, so 2 is in the hundredths. So that's the number that's either going to change or stay the same. Okay, who tells the 2 what to do? The number right to the right of him. And that number is going to tell 2 to either go up or stay the same. So our 4 is right to the right of the 2. Is it going to tell the 2 to go up or to stay the same? 2 is going to stay the same because our 4 is less than 5. Remember that from the last lecture? If the number to the right of your underlined number is less than 5, your number stays the same. So 3 and 524 thousandths is going to round to 3 and 52 hundredths. And very often my students will throw that 0 back there because if you guys remember from the whole numbers lecture talking about Bob and Felicia, Felicia gets all of her stuff kicked out of the apartment. The 0 would be appropriate with a whole number, but more appropriate is to drop that trailing 0 at the end there. It keeps your numbers cleaner and it keeps you from the possibility of misreading them and seeing 3,520 instead of 3 and 52 hundredths, and then running the risk of overdosing your patient or something horrible like that. So 3.52 is preferable to 3.520. We want this one instead. So let's keep going with our 3 and 524 thousandths. Let's round it to the nearest tenths place. So what's in the tenths place here? Remember, 5 is the tenths because our first number to the right of the decimal is the tenths place. So he's in the tenths place. Who is going to tell that 5 what to do? The number directly to the right of him, that 2, is going to tell 5 to either go up or stay the same. So is our 5 going to go up or is it going to stay the same? Well, remember, if our number to the right is 5 or greater, it goes up. If it's less than 5, and 2 is less than 5, our underlined number will stay the same. So 2 is less than 5, our 5 stays the same, so 3.524 rounds to 3.5. What if we keep going all the way out and we round to the nearest 1? So what number is in the ones place? That's our 3. And we look over to the number that's directly to the right to see what our 3 will do. So that 5 is going to tell the 3 what to do. That 5 is 5 or greater. So 3 is going to round up to 4. So again, very similar to our rounding with whole numbers. Again, the only difference is pay attention to your place value. Make sure that you're rounding to the nearest 10, not to the nearest tenth. Regarding adding and subtracting, again, there's not a whole lot that's different here. There are a few things that I will point out. Make sure, we talked about this in whole numbers, make sure that you're lining up your numbers based on their place value. And the best way to do that is just to line up your numbers based on their decimal. Put everything in a nice neat row with the decimal kind of guiding where everything goes. But you can see here I have my numbers in the tenths place are all lined up, in the hundredths place are all lined up, and then I have here this big gap where there's no numbers. This would be a great place to throw in some zeros if that big gap, makes you nervous, which is fine. And then we would add these straight down just like we would a regular whole number addition. So 0 plus 0 is 5, 0 plus 0 is 2, 4 plus 9 is 13, carry the 1, 1 and 3 is 4, bring your decimal down, 5 plus 1 is 6, and 2 is by itself. So we get 26 and 4,325 10,000ths. Something to remember regarding lining up your numbers for the decimal, or lining up your numbers on their decimal, is that the decimal for a whole number is at the end of it. Quite often when I have whole numbers like this, up on the board, and I have students up there trying to work on this problem, they just sort of guess at random. It's kind of like throwing darts. Like, well, maybe the decimal for 25 is here. But 25 is not the same as 0.25. If it helps, think of money. One of these is $25. We get you a full tank of gas right now. One of these is 25 cents. Now, if you're my nephew, 25 cents is still good because it gets you 25 rides on the penny horse at King Soopers. But if you owe somebody $25 and instead you give them $0.25, they're probably going to be cranky with you. So the whole number, the decimal for a whole number, always comes at the very back of that number. So 25, we would write 25.0, or 3, we would write 3.0. 179 would be 179 with the decimal at the end. Or 56 would be 56 with the decimal at the end. So make sure that you are paying careful attention to that when you're lining up your problems. Okay, so what do we do when there is nothing to subtract? I see this a lot with my students. They'll get a problem like this, 36 minus 4.57, and they're very good at lining up their place values. Here's the 6 and the 4 in the ones column, and maybe they even draw in the little decimal there, and then we go to subtract it. Okay, well, there's nothing out here, so 7, 5, bring down my decimal, 6 minus 4 is 2, 3, done. Is that the correct answer? Is that the correct technique? If you're not sure, go grab your calculator and check it. 32.57 plus 4.57. If this is correct answer, it should give you 36. It's not going to give you 36. It's going to give you 37.14. So this is not the proper way to tackle a problem like this. Let's look at the correct way. Because just because there's nothing written there, it doesn't mean that we can just ignore it. In reality, what is written here behind that 36? Well, 0. And can we just subtract 7 away from 0? No. If we have 0, we can't take 7. Right? If you have $0, I can't take $7 away from you. So remember this from the whole numbers lecture? We have to go all the way over to the 6, borrow from the 6, and then come back. Turn the 0 next to him into a 10, borrow from him to make him a 9, and turn the next 0 into a 10. And now we can subtract. 10 minus 7 is 3, 9 minus 5 is 4, write down your decimal point, 5 minus 4 is 1, and then 3. Now, plug that into your calculator. If we do 31.43 plus 4.57, now we should get 36. Let's check. 3 times 7 is 10, carry our 1, 1 plus 4 is 5, 5 and 5 is 10, bring down the decimal, carry the 1 again, 1 plus 4 is 6, and then bring down our 3. Hey, look, we did it right. So make sure regarding adding and subtracting with decimals that 1, you're writing in your decimal, that's important, and 2, that when you have nothing back here, you're writing in zeros, because in reality there are zeros at the end of that number. So let's move on then to multiplication and division. Again, this is going to look very similar to what we talked about in the whole numbers lecture. One thing that's important to remember with multiplying, you do not need to line up your numbers based on their decimals or their place value. So this over here on the left side of the screen, that's not necessary and will probably confuse you and throw you off. This is better right here, where you have each number over to the right as far as it will go. So let's take a look at our multiplication and see what we do here. Because we got decimals here, we need to figure out where we put them in our answer. First step to our multiplication problem is just to solve it like a regular multiplication problem. So we'll start with our 2. 2 times 5 is 10. Write down the 0. Carry the 1. 2 times 4 is 8. 8 plus 1 is 9. Write down the 9. And then 2 times 3 is 6. Good. So far, so good. Now, remember from whole numbers, now we're going to start with our 4. And before we do that, what do we have to do? We have to add a 0. And now we can multiply our 4. So we'll do 4 times 5 is 20. Write down the 0. Carry the 2. 4 times 4 is 16. 16 plus 2 is 18. We'll write down the 8. Carry the 1 on top of the 3. 4 times 3 is 12. 12 plus 1 is 13. There's nothing to carry, so we'll write down the whole 13. And now remember, we have to add all of that up. So 0 plus 0 is 0. 0 plus 9 is 9. 6 plus 8 is 14. Carry the 1. 1 plus 3 is 4. And 1 by his lonesome is 1. So far, so good. Now we need to figure out, where does the decimal in this answer go? We just pick one row. I like the 3.45, so I'll stick it down there. How do we determine that? Well, the first thing we have to do is look and see how many spaces over to the left did our decimal move from the back of our number, from right here. So in our 3.45, our decimal went over twice, 2 times to get to where it was. How about down here? Our decimal only moved over once to the left. So 2 times on the top row, 1 time on the left, on the bottom row. We add those together. That means that our decimal is going to move to the left 3 times. He's been hanging out down here, waiting for somebody to tell him what to do. So our decimal is going to move over once, twice, 3 times to the left, and our answer will be 14 and 49 hundredths. And that's how we determine where we put our decimal when we have finished multiplying. We count how many times over did it move from the right. Up on the top, moved over twice. Down here, only 1 time. Let's look at one more example just to make sure that we're comfortable with determining where our decimal goes. So here we have 0.456 times 0.23. Let's do our multiplication first. So starting with the 3, 3 times 6 is 18. Carry your 1. 5 times 3 is 15, plus 1 is 16. Carry your 1 again. 3 times 4 is 12. 12 plus 1 is 13. We'll write that whole thing down. We could carry to the 1 and then multiply 3 times 0 is 0 plus 1. We don't have to. Now, let's start our next row. Starting with the 2, remember we have to add a 0 first. And then we'll do 2 times 6 is 12. Write down our 2. Carry our 1 on top of the 5. 2 times 5 is 10. 10 plus 1 is 11. Write down the 1. Carry the other 1 on top of the 4. 2 times 4 is 8. 8 plus 1 is 9. Write down our 9. And then 2 times 0 is 0. Our last number here, our 0, we can just skip that because anything times 0 is 0. So you'll just have a third row that's nothing but zeros. Okay, now that we're done multiplying, next step is to add all of this together. So 8 plus 0 is 8. 6 plus 2 is 8. 3 plus 1 is 4. 9 plus 1 is 10. Where does our decimal go? So let's look at our 2 numbers here. Let's look at 4, 5, 6. From the very far right of the number, our decimal moved over 1, 2, 3 times to get to where it is. How about our second row? From the very far right of the number, our decimal moved over once, twice to get to where it is. So that means our decimal in our answer, who's hanging out back here waiting to know where to go, is going to move over a grand total of 5 times. Add our 3 and 2 together to get 5. So our decimal will move over 1, 2, 3, 4, 5 times to land there. And our final answer will get 10488. If you have questions about where do I put the decimal, how do I know if I did it correctly, come drop by office hours or email me and we can talk about it some more. Let's look at division. There are 2 different kinds of division that you can see when you are dividing with decimals. You can either divide a decimal by a whole number or you can divide a decimal by a decimal. We are going to look at both. We'll start with dividing a decimal by a whole number. You would divide like normal, like it was a regular whole number. When you come to the decimal, bring it up into the answer. I'll show you what I mean by that in a little bit. And if you run out of numbers to drag down and you still have an answer left from your subtraction, you're going to just add a 0 and keep going. It's one of the nice things about dividing by decimals. You can just keep adding zeros and keep dividing until either you find your answer or you have a number that just repeats forever and ever. So let's look at this guy right here, 16.5 divided by 4. So like I said, treat it like a whole number. So first step, 4, will 4 go into 1? No. Okay, how about 16? Will 4 go into 16? Yes. 4 will go into 16 4 times. 4 times 4 is 16. Subtracting, get 0. Now we have our decimal right here, so we're going to go ahead and bring him up into our answer so we don't forget him. And then we're going to bring down that 5. And now we say, does 4 go into 5? And it does. 4 goes into 5 1 time. 1 times 4 is 4. Subtract and get 1. So now what? We don't have any numbers up here to bring down. We have a 1. Do we just write 44.1 remainder 1? No. This is where you get to add a 0 and bring that down. So now we have 4 into 10. How many times will 4 go into 10? Well, twice. 2 times 4 is 8. Subtract and get 2. We still have a number. What do? We add another 0 and bring it down. Okay, 4 into 20. 4 will go into 20 5 times because 4 times 5 is 20. Subtract, and we're done. We have a 0 here, no more numbers to bring down, we're done. So our answer is 4 and 125 thousandths. So hopefully you saw those 2 things that I mentioned shown in this example. 1, how I brought the decimal straight up into the answer as soon as it came to it. And 2, when I ran out of numbers to bring down after I brought down the 5, I just added 2 zeros and brought those down instead. Now let's look at dividing a decimal by a decimal. This has one little step before we can actually divide, and that's because you can't divide a decimal by a decimal. If we have a decimal in our divisor up here, this won't work. So we are going to move the decimal in the divisor until we make it a whole number. We're going to move it to the right. So in this case, we have 0.8. We're going to take that decimal and bump it over 1 spot to the right. And now instead of 0.8, we have 8. But if we do that to the outside of our division problem, we have to do that to the inside of our division problem, him. If we don't do that to him, he's going to be lonely. And more importantly, your answer is going to be wrong. So the decimal here, we're also going to move 1 spot to the right because we did that with the 8. And now we've got, instead of 0.8 into 3.92, we have 39.2 divided by 8. This is something that we can work with. And let's take a look at that. So 39.2 divided by 8. To start with, how many times will 8 go into 39? 8 will go into 39 4 times. 4 times 8 is 32. We'll subtract and get 7, bring our decimal straight up into our answer, and bring our 2 down. Okay, how about 8 into 72? Well, that's 9. 8 times 9 is 72. Subtract and get 0. There's no more numbers to bring down, so we're done. 39.2 divided by 8 is 4.9. And most of the problems that you will have in your homework should be something similar to this. Pretty straightforward, short answers, not something that's very long or clunky or weird. You shouldn't have a lot of goofy answers. If you are getting big, long decimals for your answers, plug it into a calculator and double check. And you should be getting at least one place value into a decimal for all of your homework, because all of your homework will require that. So as always, make sure that you're double checking your work. Grab a calculator, do 39.2 divided by 8. I want to look at one more example of this just to make sure that we're very, very clear with our technique. So here we have 0.12 into 0.543. Again, this decimal here in the divisor, the dividend, is a problem because we can't divide a decimal by a decimal. So in order to take care of that, we move that decimal to the right however many times we have to in order to get a whole number. So in this case, our decimal is going to go over once, twice to the back of our 12 to give us 12 instead of 0.12. The same thing is going to happen on the inside of the division box. Our decimal will move over once, twice, and land in between the 4 and the 3. So now if we rewrite our problem, instead of 0.12 and 0.543, we have 12 and 54.3. This we can multiply accordingly because we don't have a decimal in the divisor, or in the divisor in the outside of the problem. So let's take a look. 4 into 12 into 54.3. Sorry. Well, 12 won't go into 5. How about 54? How many times will 12 go into 54? Well, it'll go in 4 times. 4 times 12 is 48. And 54 minus 48 will give us 6. We come to our decimal here, so let's bring our decimal straight up into our answer. Bring our 3 straight down. So now we have 12 into 63. How many times will 12 go into 63? It'll go in 5 times, because 5 times 12 is 60. Subtract and get 3. And now what? We're done. We got no more numbers to bring down. What's our next step? We are going to add a 0 and bring it down. Okay, how about 12 into 30? How many times will that go? Well, that'll go twice. 2 times 12 is 24. 30 minus 24 is 6. And then add another 0, because we don't have anything else, any other numbers to bring down. Bring it down to our 6, and we have 12 into 60. 12 goes into 60 5 times. 5 times 12 is 60. Subtract, and we get 0, and we're done. So 54.3 divided by 12 will give us 4 and 525 thousandths. That's our final answer. As always, grab your calculator, plug it into your calculator, make sure that you got your answer correctly. Okay, that's our division. Let's look at going from a decimal to a fraction. So let's say we have this guy right here, 45, 0.45. We want to write it as a fraction. There are 2 steps to this procedure. And before we look at it, I want to make sure that we've got one thing really clear because we haven't talked about fractions yet. What is a numerator? What is a denominator? The numerator is the top number in the fraction. The denominator is the bottom number in the fraction. So we need to find both the numerator and the denominator for our 0.45. The numerator is everything to the right of the decimal. All of that's going to be our numerator. So everything to the right of the decimal here is 45. That's our numerator. How about the denominator? The denominator is the place value of the last number in the decimal. So what is the last number in the decimal? The last number is our 5. What place value is he? 4 is in the 10th place, 5 is in the 100th place. So our denominator is going to be 100. So 45.45 is the same as saying 45 hundredths. Now, because we have not talked about fractions yet, you do not need to worry about reducing your answer down. You can give it to me like this in your homework, and that is just fine. If you were interested in reducing your number down, we can divide 45 over 100 by 5 and get 9 over 20. We will talk about that more in detail next week. Like I said, for now, don't worry yourself about it too much. Let's look at another example, 5.206. Now we've got a decimal, we've got a whole number. What do we do with that whole number? Well, let's start with our decimal first. We'll take a look at him. So remember, everything that goes from the right of our decimal is our numerator. So in this case, our numerator is 206. And then how did we find the denominator? The denominator was the place value of the last number. The last number is 6, and he is in the what place? He's in the 10th, 100th, 1000th place. So our denominator is 1,000. Okay, what about him? The whole number there, that 5, he's our freeloader. He doesn't do anything. He doesn't contribute to this problem. He's like that guy that lives in your brother's basement. Is always on his couch and asking you to drive him to Walmart. He doesn't do anything. We just have to drag that whole number along at the end. So once we have finished converting our decimal to a fraction, we got to bring him to 5. 5 and 206 thousandths. And then if you are interested in reducing, you can divide by 2 to get 5 and 103 over 500. Again, if you are not familiar with reducing or don't know how to reduce, that's fine. Don't worry about it. We will talk about it next week when we talk about fractions. So make sure that you pay attention to this, because a lot of the time I get students who just lose their minds when they have a whole number and they have to convert the whole thing to a fraction. I get a lot of like 5 over 206 or 206 over 5 or 206 over 1 and 5. Nope. The 5, he doesn't do anything. He's a freeloader. The only thing you're interested in is the decimal itself. Okay, what if we want to go the other way? We want to turn a fraction into a decimal. Well, in order to do that, we're going to divide the numerator by the denominator. So your division setup will always look like this. Denominator on the outside of the division box, numerator on the inside of the division box. That's what we see here with our 5/8. We want to turn 5/8 into a decimal. We're going to lay it on its side and divide. With our denominator on the outside, our numerator on the inside. So let's look at that really quick. 8 into 5. What is 5 divided by 8? And hopefully you look at that and say, but wait, 8 doesn't go into 5. I can't do that. Perfect. That's exactly what we want. Because we don't want a whole number, we want a decimal. So we're going to start with our 8 into 5. We're going to add a decimal and a 0. Bring our decimal up into our answer and start dividing. How about 8 into 50? Will that work? 8 times what is close to 50? Well, 6. 6 times 8 is 48. Subtract and get 2. And then we'll add another 0 and bring it down. Okay, now we're looking down here. 8 into 20. How many times will 8 go into 20? Well, 8 will go into 20 twice. 2 times 8 is 16. So we'll subtract and get 4. So now add another 0 and bring it down. Now we have 8 into 40. How many times will 8 go into 40? Well, 5 times. 5 times 8 is 40. Subtract, we have 0, no numbers left to bring down, so there's our final answer. 5/8 is the same as 625 thousandths. And make sure when you're working on your homework that you're using some good critical thinking skills as you're working on your division. For example, 5/8, there's no whole number there. We just have a fraction. So our answer should just be a fraction. If we had 4 and 5/8, what would our answer be? It would be 4 and 625. But the 4 in this case still works as a whole number. We don't do anything with him. We just have to add him to the decimal when we're done dividing. So make sure that you're thinking very logically about your answer. Did I start with a fraction? Then I should end with a decimal. Did I start with a fraction and a whole number? Then I should end with a decimal and a whole number, like we see in our 4 and 5/8. Let's look at an example that has just that. So here we have 12 and 4/5. Like I said, the whole number is our freeloader. He doesn't do anything. We just have to drag him to the end of our problem. So we set up our division, denominator on the outside, numerator on the inside. And again, 4 can't be divided by 5. You can't put 5 into 4. So we'll start by adding a decimal and a 0. How about 5 into 40? Oh, make sure you bring your decimal up into your answer. 5 will go into 40 8 times, because 8 times 5 is 40. Subtract, get 0. No numbers to bring down here. We're done. So 4/5 is 0.8. But remember our freeloader 12, we have to drag him along as well. So our final answer, like you see here, is 12 and 4/5 is the same as 12 and 8/10. So if you have any questions, please send me an email or come by office hours. Like I said, there's not a whole lot that's especially different with our whole numbers compared to decimals, but the few things that are different, like knowing where to put your decimal after you multiply, or making sure that you move your decimal when you are dividing a decimal by a decimal, those things will make or break both your assignment and your grade. So pay close attention to the things that I really strongly emphasized, and if you have any questions, drop by office hours. I'd love to see you.